Alright, another draft physics video production. Alright, it's going to be more two-slit stuff, and it's really important, frankly. This is the first part where I can demonstrate that my theory has completely debunked, a piece of classical, conventional physics, and just demonstrate how it's all wrong-headed. All the premises are wrong. The whole theory is slop and a much simpler and very mechanical and very particleistic theory. Just, nail in the coffins. The zombie gets out of the coffin, the particle zombie, and reverses the situation. Totally puts wave in the coffin and nails it shut, and this time it's for good. However you want to draw the cartoon. But yes, it's over for this whole Bohr Woo model, because one of their fundamental cornerstone bricks has been dissolved and their whole bullshit building is going to fall down. So it's big, it's huge, really. And somebody should start recognizing that. Somebody with a intelligence. The intelligent people should start recognizing that, yes, that's what has been accomplished, and the edifice is crumbling. You've cracked the glass, and now the cracks are going to start going all over the place, and eventually the windshield's going to just fall into a bunch of little pieces. That's the analogy for where we are now. It's done. It's, this is the decisive moment in time. This is the place where finally, you banged on, smashing concrete. You smash it and smash it, and all the smashes sort of add up because there's one smash that all of a sudden works. And everything just falls apart because you've done the work. You're beating at it, and finally you build up enough damage, and then it all just falls apart. Anyway, lots of analogies. Alright, so some idiot or asshole or retard posted this same fucking comment on 4 different videos, which I really hate that shit. And again, it's just a bullshit comment. Linking me to a video, so fine, I'll play the video and play how it's a piece of shit. Steaming, crappy, conventional bullshit. So it's an Indian guy, so, everybody has to do their own little, whatever, their little ethnic thing. So he says, "Sir, please reply to this interference experiment done by experimentalist H.C. Verma." There's no experiments in the video, okay? They're just, the guy shines the pattern on the ceiling, and then they put in, they Photoshop an image of the actual, better image of the experiment. And he says, "In starting 5 minutes, please review it. It clearly showed dark fringes." Yeah, I don't know where you said or think. I don't think there's such a thing as dark fringes. The point is when you're adding, in the 2-slit experiment, for example, contributions from 4 different sources, okay, then you can have variations in terms of the strength of the signal. And the dark spots won't be darker, okay? Nothing gets darker, all right? Things just get 4 times brighter, which makes a big difference. 4 times brighter makes 2 things look very different than when it's, 1 versus 0 versus 4 versus 0. Looks very different. Or 2 versus 1, and then you make it 4 versus 1. Is probably a better analogy. The 1 is a lot less obvious, when it's 2 to 1 versus 4 to 1. All right, so leave us go to the videotape. That's not the videotape. This is okay. So this is where he's shining it on the ceiling just to give the class some perspective. Now this is a guy, he's speaking English, but Indian peoples. I guess their language is so different vocally that often they don't speak very good English. Even when they're speaking really good English, which the guy is speaking really good English, yeah, sorry, it's not always understandable English, and it's unfortunate. No slight. This is it's great that India gives a shit about physics, but unfortunately they give a shit about American physics. They're not doing their own thing. They're thinking I guess because America landed on the moon or something, they must know everything, and they must not have made too many mistakes when they made a ton of them. Anyway, so the interesting thing is this picture of this pattern. It's a nice picture of a pattern. I probably should need to speed this up, but amplify the volume a little. It's sort of interesting. You can see the dark bands are getting larger, and the light bands are getting smaller, which is kind of strange. Because you're saying, well, they're both supposed to getting bigger. They're both getting stretched, and so I made this simple point that physics already should have fixed this. Any physicist should already know that whenever they're going to demonstrate this experiment, they obviously should demonstrate it by what's happening. They have a sine theta in the glaringly in their formula, and yet they don't acknowledge the fact that they should be looking at the pattern on a curved surface. That looking on a straight surface ends up because you can sort of just get it. If I just drew an angle from here to here, you can just understand that it's this distance is a lot smaller than this distance. So you're stretching your pattern as you go further and further out. You're distorting it. When this is really what should be. This should be compared to this, should be compared to this, because they're all equal distant. And so you don't have any distortion. And that's really important. So that should have been the first argument, is that you never display this thing. When you're doing this experiment in a technically precise way, you should always bend the surface. So you have these things at equidistant. That means their intensities. See, this kills intensity as well as stretching the pattern. Right? You can't see the pattern because these photons are now being spread over a huge area, and therefore we won't even see them. So you won't even see them, let alone see them in the right size. So some of the photons will become invisible because you spread them over so much space, and you're also stretching them. So it's two evils, so to speak, two corruptions that ruin understanding of the formula of the situation. Now this guy also talks about, in the end of the video, I don't know, we'll get to it or not, but one of the students asked about this pattern going infinitely, and he kind of concedes that it does, but we can understand that it doesn't matter if it goes infinitely, because we know the pattern is here on this line, and the infinity, in fact, I could draw this either way, right? I could draw this last spot as being a light or a dark. But the truth is all the infinity will be inside that light or inside the dark. The infinity will not be a changing infinity. The pattern will not change for the whole infinity. So if you integrated through this whole thing, called this an infinitely, you kept slicing the angle in half. Like you say, you take this 1 degree angle and you slice it in half, and then you slice it in half, and then you slice the halves in half, and you do this infinitely thing. You'll get the same end pattern. It'll be on or off. Okay, it's either going to be, it'll be a certain intensity, and that intensity will not change. So the photon's intensity at any one of those infinite locations will be exactly the same. So it's a totally uninteresting infinity. Okay, so that's another part that just makes it kind of silly, is to imply the pattern goes infinitely, when no, the pattern completely stopped in the infinity. There's no more pattern. There's no more on-offs going infinitely. All you have is a certain number, and that's all you'll have. You'll have a certain number of on and offs, and that's all you will have. And that number will be decided not by the wave centers, okay? not by doing this idiotic math, which doesn't work, where you take the center of the waves and then you consider them the point sources. That math doesn't work. No, the math that works, that actually predicts the correct pattern, is math that says these are the point sources, right here on the surfaces, as I've been saying for 10 years. And didn't really understand how, I understood I was right. I just didn't understand why I was right. And now I do. But that's it. So there's 4 point sources. Of course, that means you're going to have 4 times the potential for creating photons when you add up all 4 sources. So you're sending parts, and the more parts you send, you know, this, when you send, say you send these 2 things as parts, well, the trick is when you add the 3rd one, it can add to this and it adds to this, right? And if you add a 4th one, it adds to these parts, plus it adds to these parts, plus it adds to these parts. That's what amplifies your signal. All right, so as a premise, I mean, that right there, I've already explained this, the experiment, right? So I've said this before, but the distance here will dictate this, you know, the bigger pattern, okay? And you're just adding smallness to this by adding slits. So say if I made the center impediment really huge and I made the slits very small, then obviously the difference between the 2 patterns is going to be almost nothing. The difference, this distance, won't be very different from this distance, and therefore both will be sending light to, you know, the same kind of blocks. But as soon as I change this distance and make these 2 distances very different, that is, I make the slits wider or I make the impediment smaller, however you want to look at it, then I'm going to get very different patterns. This one's going to create big places where photons went, and this one's going to create very small, well, lots of the wavelengths, lots of blocks. So obviously, as I've pointed out, the big reveal is that this distance tells you, the distance between the 2 furthest point sources tells you what the small blocks are going to be, and this distance tells you what the envelope will be. And obviously you'll get the traditional pattern, which we are always talking about, the pattern where you have a big off. Okay, you have a central maxima, and then you have an off, and then you have a pattern, you know, the real 2-slit pattern that has this part where it's wiped out, you know, where there's nothing. And that's the big one. It also can be explains, you know, the difference between the single slit and the double slit is just the center is bigger in the single slit, and the center is bigger in the single slit because it starts with a 0 line and it creates a pattern this way and a pattern this way, where the double slit just creates the one in the middle. Very different. So this one is a 2. It looks like one big one, but it's really 2 constructive interference patterns smushed together. All right. So that's why the center thing is big, because there's actually 2, okay, nodes there, okay, coming off of 0. So there's no dark band in the middle. There's just 2 light bands smashed together, one going this way, one going this way, because the light is going directionally. These 2 lines go, both of them go in that direction, and from the surfaces when I have 2 point sources. So just imagine the single slit here. These 2 go in that direction, and then 2 sources, potential sources, both go in this direction. And so that's why you have the bigger node in the middle. All right. So we'll call that a first introduction, and now proceed. And I have to find this so I can erase some of this, because it's probably just, I can just redraw it again because it doesn't erase all that well. So that'll be convenient to re-emphasize the point. All right, continuing. So let's see if we can find this should be the double slit image. So again, he's doing it on the ceiling, so obviously this isn't an image of what he had on the ceiling. Should be the double slit in here.
The center is much brighter. And what?
Okay, so we have to see if we find the double slit. He did the double slit. I saw him do it. Got to be here. Why do they do that? That's not in here anywhere. They sit there and show you frickin' other videos. I don't want to see what's another video. Well, anyway, let's just do it.
And then you have small these things. So that's the difference. That difference in pattern you should note. Yeah, now we can put on the light.
That was the double slit? No, it wasn't.
So let us understand.
This is the double slit.
Where our school textbook.
There it is.
Let me try with this double slit. Yeah.
Alright, so here's a good image of it. Now it's kind of funny that you don't see the other, you see the big off here and then on again. So we understand that the single slit's creating the envelope pattern is what they call it. So the envelope is this node plus this node. See, and it's a single slit, so the node is 1/2 the size, okay, because the node, the single impediment is a 2-slit experiment in the sense that it's got the big node in the middle, the double node, and the other one should be over here and it's not there, but it should be over there, but regardless, for whatever reason, they had the angle off a little bit. The light didn't do what it's supposed to do on the other side. But obviously this big difference between single slit and double slit is this fact that you have this huge break in the pattern, indicating that it's more than one pattern, 2 patterns. And so the width of the single impediment, the thing in the middle, that's dictating this secondary pattern. So if you make that bigger, you'll make the nodes smaller, and it'll contract the space that these little bricks can be in, and so you'll have obviously fewer bricks because fewer bricks will be in the space before you have this other thing show up. And if you make the impediment wider, okay, then you can fit more bricks inside, and you'll have more, 13, 14, 15. So there's each pattern you'll see will be different, and it'll be different for that reason, because you're really saying what's the container that you're going to put your little ons and offs inside of. And then you can make the ons and offs different sizes by changing how wide the exterior surfaces are of the 2 slits, the maximum distance from surface to surface, and that'll tell you how big the little bricks are. So you make the bricks smaller, get more inside by making the slits bigger, or you can make the space the bricks are fitting in bigger by making the slit smaller, and the impediment smaller and smaller. You make the impediment smaller, you widen the envelope and create more space for bricks, and that's all works. And it's all works because of just scatter at the surfaces. So assuming light is scattered at the surfaces completely explains this pattern, which their theory doesn't do. Alright, so we'll go in. He said like 5 at 5 minutes. Now, I guess he was assuming that this pattern proves it because, so obviously you can see there's obviously the darks in here are sloppy. Okay, you can see that they're not perfectly dark in all these spots. And yes, this is very dark. Well, that's my theory, is that should be very dark. So that's not the place where I'm saying you're not creating a place in space that was light. That was a place where when you open the second slit, you make it darker. That never happens. Okay. So jump ahead to the 5-minute mark as he says something. I think he starts to draw, and we can see from the drawing how it's the same wrong-headed theory.
Start with the character of light in much more detail. We say that light is not like particles which go in straight line if there is no force on it, Newton's law, but it's a kind of a wave.
All right, so obviously that's what they're saying, right? It's not straight lines, it's not quanta at a frequency, it's not a mechanical thing, it's some wavy thing that's some perturbation in some magical field. The electric field and the magnetic field are somehow doing some kind of weirdy thingy in one little location, and that location is moving the speed of light in a direction. So some kind of crap like this is happening in a field of something, and the field of something is somehow also, it's moving this weirdness going this way, and it's moving that weirdness in a direction at the speed of light.
The wave is in terms of electric field and magnetic field, right? And how much is the electric field? Together with this question, I must specify two things: where and when. Okay, if the light is coming from this source to me, then in the entire room there is light. So if I ask how much is the electric field or how much is the magnetic field, where? Here.
Okay, so this was kind of interesting about his take on it, right? So this isn't how a lot of people teach it. So he's teaching it based on the intensity of the field. Okay, so the field is doing this thing. It's either going up or it's going down. Okay, or it's in between the two ups and downs. And it's moving in this direction. And his simple kind of argument is when they go into the slit or the thing, okay, when they interact with whatever it is you're having them interact with, these things that are doing this, they're in phase when they started. So this one is going up and down at the same, at the same phase. When this one's up, when that one's down, so they're together. And then you're going to put them through a process where obviously this path difference, which he's not dealing with, he's just ignoring the path difference, saying forget about the path difference because that's not what we're really talking about. What they're really talking about is what do you end up with here, is in terms of arrows up and arrows down are neutral. And the fact is that it'll be a photon that got here earlier and a piece from some earlier photon is going to end up meeting up with a right now one. So at this time, this is one time. There'll be different times, T2 or T3 or T5, where these things actually will end up here at the same time. So it has to be different somewhere, which is a logical argument, right? You can't really make this argument that they got here at the same time, they traveled different path lengths and did something at the same time. They obviously can't do that. So one would have to be behind the other. One would have to be, like, for example, one could be doing this, and the other one could be doing this. That is, in time, one of them shows up and is doing this, and then at the next moment, the second photon shows up and fills in this. So you could argue that this started off with 6 things, that hit this surface. These 3 won't be any good because time is going to ruin those. Well, I should have done it the other way around. Alright, so I have, let's say, 6 of them just to make it easy to draw. Okay, so these 3 are the head ones, right? And these 3, you could say, I'm well, the point will be is you can take these 3 from this side, and you can take 3 that come later in time from this side. And both of those can get here at the same time. And that would be the key to putting these 3 where these 3 weren't. And so now you have a whole photon again. So in some sense, that's a reasonable way to look at it. But clearly the path length is what's deciding all of this wavelength on, wavelength off thing. And we're just talking about phase. And so it doesn't really matter which way you look at it. I think time sort of is irrelevant, so I wouldn't even bother thinking that way. You just look at these distance lengths, and you're just saying if these were constant streams, you wouldn't even think about time. So if the photons were being produced, with 500 of these little things in a row, constantly being produced, you'd understand that, I can see a photon when it's 6. So 6 into 500 will tell me how many photons are coming through. But that's all I need I just need the stuff to show up at the same time, in phase or out of phase. So out of phase is, no photon. In phase is photon. And that's all they're really talking about. But I'm just saying his approach is a little different.
Or here, or here, or here, or here. I have to specify the position where I'm asking the speeds. Then when you specify the position, but then as a function of time, it keeps changing. The electric field keeps changing. And the frequency of change is very high. How much? Normal visible light. How many times per second this electric field will oscillate? Any idea?
So he's asking, 10 to the 14th or whatever. Obviously, it's a gigahertzy, trigahertzes kind of numbers. All right, so he's writing stuff. That's not what we want. Blah, blah, blah. We want him to start drawing the pattern. So I guess we'll jump ahead quite dramatically to get to that. Alright, so we'll go to, I think it's at 40 something. 49, I thought it was earlier than that, but that'll have to do. Alright, I think he draws the pattern here, hopefully. No. Alright, sorry, I should have wrote this down. Let's see what he's got on the board here, and we'll see if he drew. No, he didn't draw the pattern yet. See what's on the board here. Lots of explaining, but no drawings. Okay, so here we're drawing.
So I am only showing you a magnified version. And then I am looking at the screen here.
So he's telling you very small slits, right? And as I pointed out, the only way you can get a single slitish looking pattern, that is one that doesn't have the breaks in it, is to make the difference, to make the slits very small or the impediment very large.
So this is the central point. So from this slit, light is going in all directions with uniform intensity distribution. From this also, light is going in all directions with uniform intensity distribution.
Okay, so as I've pointed out, this is clearly wrong. It won't work. It won't create the real double slit pattern. So the big lie is we know what the pattern is. We know what you have to create, okay? You have to create that pattern that has two patterns in it. That's the actual pattern. So to draw it his way, this is what you have to create. You have to create this pattern, right? You have to create this pattern that has these breaks in it. You can see that, right? Well, almost. So that's what you're after. This idea of two waves, okay? And he's drawing them as point sources, which I really like. So he's basically saying, look, there's the center of the wave. The wave has radii, okay, that you can understand, where it's vectors that are straight lines making the curved line, so to speak. And there's this even pressure, and the even pressure moves out, and we can do the Young thing of spreading that out and making an image, but that image will not be this pattern. That image will not include this very important feature at all. And it won't get this size actually right. So it has two huge failures, because the actual pattern, okay, the actual math that works precisely, accurately, completely, the math that gives you the exact correct pattern, predicts it correctly, relies on these being the point sources. So it's as if the waves, were coming off, I mean, do I really have to draw you a magnified view of it? Here's the surface, here's the opening. The wave would have to be half in on the surface and half in the opening, okay? I mean, that's not how waves are produced. That's not how the wave would be created. So wave will not work, because I have to move that wave. Okay, the wave that would come out of here has to be moved here. That's what's going to work. So it's the surfaces, and there's obviously 4 surfaces, which works out perfectly. And those are the things contributing. The 2 widest distances tell you how big the little blocks will be, and the 2 inside surfaces tell you that you'll have, these nodes will be decided by this surface, how many of those there are. Okay, and this first one will be a double. Okay, so the envelope pattern, the big blocks here, will be decided. Okay, the size of them will be decided. There should be that size, even same size. 2 of them here, same size here. That's decided by this distance. Okay, the distance of this opening, the impediment. How did I draw that wrong? Well, anyway, you get it. And here's the opening. And the size of these things will be decided by the 2 exterior distances. And that's it. That's the math that works. It has nothing to do with waves. It has to do with light coming in and pieces of the photons, breaking of pieces, the quanta, the little bits of the photon. One little bit goes that way, one little bit goes that way, goes this way, goes that way. They all go to different locations here, and we know that here should mean here. And when they go to those different locations, you can make a photon when they're in phase, and when they're out of phase, you end up with the photon bits on top of each other or in some other configuration that can't be seen. So you have no destructive interference, you just have constructive reconstruction or no reconstruction. Reconstruction, no reconstruction. Reconstruction, no reconstruction. And it'll always be on this finite arc, and you can know exactly how many of these bars will be created by just seeing how many wavelengths fit in this distance. So you calculate how many wavelengths you have in this distance difference. That'll tell you how many bars you'll have on this arc. Obviously you multiply it by 2 and you'll know what the whole pattern will have as a possible number of blocks of light. The end. Wave theory is dead.
Now I take a point on the screen and ask, what is the intensity here? So what is the electric field here? So I will join this point to these two slits and then ask, what is the electric field reaching at this point P from the first slit? What is the electric field reaching from this at this point from the other slit? We'll add it vectorially and see what is the resultant electric field.
Right. So, it sounds reasonable, but it's wrong. And I think they know it's wrong because they've never really shown us this exact calculation. Going from the center of the slit, using the center of these openings as the point sources, as the place where the vectors start, that math won't work. It won't give you it won't accurately predict where the little blocks of light will be. So it's always been a fraud and a fake, in the sense of it's never been technically correct. It's not just that I'm pointing out that this is a much better answer. It's much more rational, it fits, the math is better, it predicts better. It's that this never predicted correctly in the first place, so they should have known it wasn't right. And it certainly, even if you did this, even if you assumed that the double slit pattern wasn't this pattern that had the breaks in it, right? Even if you assume it didn't have the two patterns and you just thought of it as one, like a single slit. Even if you make that assumption, it still produces the wrong answers. They're still incorrect, okay? Because those vectors are not going to give you small enough blocks. And so you'll be putting your blocks in the wrong places.
Right? That is the method I have to use. So from here, this particular light wave will be picked up. And from here, this particular light wave will be picked up. And these two electric fields will be there. Why it is very difficult?
Okay, so it's kind of funny that he's now going to go off the subject, but it's sort of on the subject of physics. So let's keep this part just because it's kind of a useful statement. I mean, I generally like what he, the attitude of this teacher. It's just obviously he's been taught wrong, and so he's just teaching bullshit. So he draws these lines as if he has real proof that this actually works and creates the right pattern when it doesn't.
To draw straight lines on this board. Had it been a green board and a chalk, calcium carbonate chalk in my hand, I could have drawn much better straight lines. Friction is less here, okay? Friction is very small here, and I am not allowed to go the way I want to go. So
he's saying the pen, it doesn't have friction, and so without that friction, he's more subject to errors. The errors get magnified. So there's a physics explanation. So he's kind of just pointing out that simple things, just simple, stupid things, all have this physics in it. So yeah, it's a nice little statement to make. You can understand everything as its physics. Physics explains why you can't make a straight line one day and you can the next day.
But if it is chalk, I can draw much better. So if you understand those rules, those laws, those equations of friction or whatever you learn, and you look at what you are doing in 24 hours, there are hundreds of places where you can apply those equations and you see that yes, nature goes according to the laws.
Right. So it's not the equation so much. It's clearly understanding the relationships and understanding the variables. So we mentioned one variable is friction, the other would be speed, the other one would be sensitivity. You feels less, you feel more with the chalk. You feel less with the you feel more of the vibrations with the chalk. You feel less with the other thing. So if the chalk was softer, then maybe you'd have a harder time making a straight line. So it gets more nuanced and all that kind of stuff. But obviously your theory matters, and so what kind of assumptions you have are going to decide what kind of conclusions you draw. And again, physics has assumed waves. They've assumed the universe is made of some goo that's fieldy, and that somehow it has bubbles in it or something that, blah 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 blah, that do shit without any mechanism, without any energy. Jellyfish, it's all jellyfish theory. When the real physics understands that jellyfish is also there's physics that make the jellyfish. It's not elemental, this thing. There's a deeper elemental function.
Learn in my class, and it will be very enjoyable once you start doing it. How I can holding this, and how I can sitting, how can I standing, and what else. So there are hundreds of things you can.
Yes, well, whatever. I mean, it is enjoyable to understand, but it's not enjoyable to remain confused and to believe nonsense. So if you believe magicians really do make pigeons, you're doing it wrong. And that's what conventional physics is doing. I mean, it's coming up with all these silly, grambling, invisible man, magical answers that just really can't be the truth. And the real answer is, yes, the magician is torturing pigeons. He's not making them. He's not really torturing them, but you know what I mean. He is sort of abusing them.
Apply those things. Once you start doing that, you will really enjoy the physics.
All right, so now we'll jump to 49. Is there something there that's worth it? I think. I wrote it down anyway.
Cos square delta by 2 is 1, and I is 4 times I naught. Here, I is 4 times I naught.
Right. Well, it'll be 4 times everywhere. So again, this is the part where you have to understand where this theory explains that 4 times. Their theory doesn't. Okay. Their theory is you're just adding 2 photons. So why should it be 4 times? And they're just saying it is. They're not going to give you any explanation for why is it 4 times. Why does the intensity of the light, the amount of light, 4 times greater? When you have these 2 sources, you're adding source A to source B, and you end up with 4 times the amount of light. Now that shouldn't be happening. But obviously, if you understand the point sources, if you understand there's 4 point sources, well, then you can understand why that every single point source will combine with one more. It'll combine with this point source and then this point source. So the parts are adding, not just to, it's not 1 plus 1 or 2 plus 2. It's 1 plus 3 or whatever, however you want to look at it. So that's where the 4 comes from, is that these parts have more value to add up. See, if you just have 2 sources of parts, there's a whole bunch of parts that don't. So and you're saying the parts are just pluses and minuses, and you're just saying how many pluses, how many both are contributing pluses. Well, you know that all of their minuses aren't matching. But this one might be doing exactly the opposite. And so it has used up the minuses, but it has a whole bunch of pluses left over. And now you're really adding all the minuses to all the pluses here, so you're getting a lot of your photons back. So the idea is that the more parts you send, you magnify how many parts you'll be able to put together. This 2 sources limits how much you can put together. 3 sources increases it by whatever 1.5x, and then another source is another 1.5x, or however you want to do the calculation to figure out why it magnifies it. But that's why it's magnified, is because now you have the capacity not only to add parts from these 2, but from this one and this one. So you're doubling your 2 sources into essentially 4 sources.
Block 1 slit, it is I naught. allow only the upper slit. Block the upper slit, allow only the lower slit. It is I naught. Allow both the slits. It is 4 times I naught. That is constructive interference.
Right. So he doesn't say why constructive and why 1 plus 1 equals 4. But again, the reason is why is because, like I said, they already technically know this two source thing doesn't work, and that they have to use front and hurry or whatever diffraction to understand that it's really 4 sources. And then if you really analyze that mathematics, you'll find out that the sources really are the surfaces, not the center of any wave center. So it's 4 sources, which are the surfaces, are the sources.
As you look at the points which are away from the central point on the screen, the difference between S1 and S2 will start appearing. It was 0 at the central point, but now it will increase. Slowly, continuously you go up, it will increase. At a certain point, this x2 minus x1 will become lambda by 2. It's continuously increasing from 0. So if you are using 400...
So I don't know if you need to see all this, but it's basically going to say, yes, it's 4x everywhere. So each location will be 4x.
nanometer light, at a certain point on the screen, x2 minus x1 will become 200 nanometers. At that point, this will be lambda by 2. So it will be what? It will be pi. And if delta is pi, this will be pi by 2. And cos of pi by 2 is 0. So at that point, no light will reach.
So again, they're also, so this gets into their math is assuming that the width of this part that's lit up, that somehow this is much brighter here in the center, and it gets dimmer and dimmer and dimmer and dimmer and goes to nothing, and goes dimmer and dimmer and dimmer, goes to nothing. When again, you can see from the pattern that that's not what's deciding the thickness of this block of light. The thickness of this block of light has to do with the fact that the out of phaseness, you're allowed to be a certain amount out of phase. You know, you're allowed to have 450 nanometers here and 453 nanometers here and 400 and whatever 50 here. You can have little variations, and this photon is still going to be seen as 400 and whatever 35 because it's an average. But if you get these two irregular, if this one's too whacked out, like it's 200 here and it's 600 here, well, that's not going to be a photon. So this is really just telling you the area in which you're close enough to on phase, but it's not anything gradual. It doesn't have a peak and a valley. It doesn't gradually turn on and then gradually turn off. It's either close enough to in phase to be a photon, or it's not close enough and it's a 0. It's very binary. The cutoff is pretty sharp, where no, you're still too broken, too out of phase. No photons here, no photons here. Everything else is close enough to in phase. And that's why there's no gradual on and gradual off. So I think that's the point I wanted to make there. So we'll jump ahead to about here.
What I mean is, will this pattern continue till infinity, and is the reason why we can see it there?
So student asked, does the pattern continuous to infinity?
Okay.
You do.
Yeah, okay. See, one thing is I am using a plane screen.
There he says it. I'm using a plane screen. So he's sort of pointing out I'm using a flat screen is what he should say. A straight line. And I should be displaying the image on a curved one. He doesn't say that though.
And if you are using a plane screen, then the distances themselves are different. And if it is diverging, the intensity will go down as a function of distance 1 by r square, etc. So that's one reason. There's another reason which I will be just coming in maybe 3-4 minutes.
It doesn't really get to that reason, and he really does say the infinity part. So, so again, this is so critical to how it's taught and how everybody is introduced to this pattern. And I remember having this conversation 7 years ago. I don't know who with. I remember having it twice actually, so it might have even been 10 years ago when it first came up. That this pattern should be viewed on a screen that keeps everything like a movie. You have to display it on a curved screen, or everything gets distorted out here and out here. Everything, it takes stuff that should be this distance and spreads it out this distance when it's not really different. The size of a head is the same size here, and the size of an eye is the same size here. And the only way you can see the eyes at the same size, or the only way you can see something at the same size, is to keep these distances the same. And if you allow the distances to spread, everything diverges, and you just make this stuff over here look like this. So a circle becomes that versus this. So, you lose proportions, you distort. And if you want to see the pattern the way it actually is being produced, if you really want to understand it mechanically, you have to keep these distances equal. Okay? These distances have to be the same distance for you to see it as it is. And that is something, all these lectures, all these people talking about the double slit, I mean, this is so fundamental to seeing it the way it is, rather than the way, this distorted view.
Way of explaining, where does the coherence of sources come into?
I'll come. That is what I told in 3-4 minutes, perhaps I will talk about that.
So I don't know if there's a point going into that, because you emphasize how important coherent sources. So he talks a little bit about how light is formed, and the atoms are doing it. He points that part out. So the atoms are, but he thinks it happens all at once, like an atom bulges and the whole photon is created. When no, it's a series of atoms that are doing exactly the same thing to create the photon pattern. That is, they have to undulate, or however you want to describe it. They have to change their position from this position to, from this position they have to jump to this position, and they have to do it in sequence. So that's the only way you can create a photon. So the photon is going to be created by a series of events on a surface, and it's going to be created by creating, a little bit, a quanta at this location that leaves, and then a quanta later, and then a quanta later. So you can create your frequency here, okay, and you'll create your polarization this direction. So the photon traveling through space has this would be its, so they're all going this way, and the time they were launched is deciding the frequency. They had a different launch time, and the fact that the energy that was launching them had to move at the speed of light through a surface is actually creating the polarization, or the spread. So the wavelength and the polarization become proportional based on the fact that the event is happening at the speed of light inside an atom. And that sort of explains why there's polarization and how frequency is manifested. So for photons to be in phase when they leave, that is, they have to have the same, a whole bunch of atoms have to do exactly the same thing at the same time. They have to be moving, this electricity has to be moving through them at the same time. So like with current, you can understand, like, if electricity is traveling through a conductor, it's traveling at different locations. Okay, so there's lots of starting points, all the same, and let's say it's a variable frequency. If we could create one at this kind of energies, which we can't. But anyway, the point is that the electricity will be going in this direction. It'll go this way. It'll go, like lightning. It's going to go in all kinds of places through a series of atoms, and each one of those is going to be creating a string of little bits at a frequency. So the photon, this one will create little bits going this way, and this one will create little bits going that way, and this one will create little bits going that way. And that's where you get your point source idea, that the whole surface is covered with a bunch of bits that could be coming out in any direction, depending on how the electricity moves through the substance. And the more the substance has a crystal form to it, of little, shapes connected to each other, blah, blah, lines or fissures, then you can understand that electricity travels those fissures, and that might be a consistent source. And so you can have a source that ends up sending the electricity, the photons, at the same time, so they'd be in phase with each other, and their polarization might be out of alignment, but their phase would all be the same. And so that would be coherent light. And that's what lasers are good at. And so all these photons would be arriving theoretically in phase when they came to the surface. Each photon would have the same alignment when they're all hitting the surface, which gives you the potential to reconstruct them into a pattern. Long way of saying kind of a thing. Anyway, so humid that chalk melted. Interesting.
Okay, right? So I have explained that double slit pattern, and you see, since it is
So again, he hasn't explained, nowhere in the video does he explain the double slit pattern. He never talks about that dead spot, never deals with it at all.
all same, all the maxima are at the same intensity, of course in a small region, right?
In a small region. So now he's saying that inside the small region of the envelope's central maxima, they're all the same. But as soon as you go outside of that, they all go bad. And he's trying to imply that somehow that's because some of the photons are out of phase when they go in, and that the length of the photons run out. So he gets into a conversation sort of about the length of the rays, and that somehow the rays are, when they start a new ray, they might be out of phase, and that's why you get those blank spots. But still wouldn't explain it, because the blank spot is permanent. It's not like the dark spot gets light and then gets dark and like dark, like there was some variability somewhere. It's always dark. So it never produces a photon that's in phase.
And
So that's, it's just a kind of a bullshit rationalization. Alright, so we'll play the ending and call it a video. But again, just, nice guy, but he's teaching crap. Okay, it's just a fact. It's crap. It's the standard American crap.
calculation in time, and I come to S1, S2, the time difference will be large. X2 minus X1 by C. Omega into X2 minus X1 by C. And the time difference is large. Maybe I'm sitting at two different planes.
So he's just using time to illustrate path difference. Obviously, this takes a lot more time. So instead of saying path length difference, he's saying time difference, because it's the time difference that's going to decide what their phase is. So how long it took this photon is still going to be very proportional to how much distance it traveled. The distance and the time are the same thing, essentially. They're tied to each other proportionally. So it doesn't matter whether you measure the distance difference or you measure the time difference. It'll tell you the same thing about whether they're in phase or out of phase.
Looking at the same X, but wave at T1 and wave at T2. But if T1 minus T2 is large, the first wave plane has gone and the next wave plane is here. So I do not know what is the phase difference. It becomes random. If it becomes random, then all this calculation will not hold, and you will have a uniform intensity 2I0 everywhere. You will not have that constructive interference and destructive. Because at the same point P, as a function of time, the phases will change, phase difference will change. And if as a function of time phase difference is changing, it is varying between 0 and 4I0. Remember the frequency there is 10 to the power 14 and...
Okay, so it's really hard to explain exactly what he was talking about there, but he's just talking about the fact that the photons coming in phase versus photons coming out of phase, and it's really wrong just because it doesn't matter. Because all there really is, as stated, is constructive reconstruction. There's no destructive interference, so nothing is wasted on anything called a destructive interference. So it's just constructive reconstruction. So what he's really just trying to describe is that you're sending your light, and the light is presumably all in phase, okay? But the catch is, and he's saying, but this length is a certain length, and once this length runs out, the next group might not be in phase, okay? The next group won't start. This distance might be arbitrarily long or short. So if you were to try to realign this photon with this one, you couldn't realign them because this distance isn't standard. The distance between the start of one photon and the beginning of the next photon. And so they would be out of phase. So this one would be aligned up this, off this one's phase. Okay, and therefore they couldn't be combined. But that's true anyway, right? Every time the experiment's really performed, there's photons that are out of phase going into the experiment. And the simple point is the pieces will go to locations, and the bottom line is just going to be that you're still only going to combine ones that are or are not in phase, and you're restricted by that you're never going to have enough volume. The only ones being affected, again, just remember, the ones going by the surface. So it's a small percentage of the total photons that are actually creating the fringe pattern. That's why most of the light in the single slit ends up in the very middle. Obviously in the double slit, the impediment's wiping out the strongest light. So it's only the fringe light creating the pattern in the first place. So you don't have to compete with the center light as much because it's dimmer center light. You can sort of understand that that's a huge difference. So you don't get just nothing. But the fact is that this pattern does get very dirty, and you will find lots of light in these locations depending, okay, I mean, how good a contrast you have will really be dictated by how good a laser you have. So how many of the photons are in phase to going in will really dictate how much contrast you have here and here. Between the light and the darks, how good the contrast is really going to be dictated by how much in phase the light is. And the less in phase it is, the sloppier your pattern's going to be. But it won't be no pattern. It'll just be a duller pattern.
This time period, lifetime is 10 to the minus 8 seconds and so on. So if it keeps varying as a function of time between 0 and 4 I naught, what I will see is only 2 I naught. Okay, so this is called coherence. If the phase difference between the two waves is independent of time, then we say that yes, these two waves are coherent. Even if their individual phases are randomly changing, the difference remains constant, remains independent of time. We say that the waves are coherent. There's another story to this coherence. That suppose I have a source, and the source is this big. This is the source of light. And I'm looking at, say, this point. Now light is reaching from this portion of the source, light is also reaching at this portion of the source. And maybe if I have a filament bulb, and this portion of the filament and that portion of the filament, they are not talking to each other. It's independently, it's heated, it's radiating, it is independently radiating. So what is the phase here? Something is coming from here, something is coming from here, and these do not have any phase relation.
Right, so he's basically just saying they're both different fires producing light at a different time, and therefore they're not going to be in phase to start with necessarily. The two photons will be out of phase. But again, to really understand this, you have to understand that the phase of the photons is irrelevant, but you're really talking about the phase of the quanta itself. And some of the quanta still will be in phase, even if the photons are out of phase, especially if you're using light that has more than one wavelength in it.
Okay. So it's difficult now. Now it's not coherent. Okay. So if you have this kind of source, and you think that this is S1, this is S2, it's not going to work. So you have to have a narrow source first. From the narrow source, if you need wide, put a lens and make it wider, aperture you can increase. But at the source itself, where the atoms are de-exciting, you have to have a narrow source. Otherwise, your initial beam is incoherent. These things will come with laser.
So the thing that makes light tend to go coherent is the fact that electricity takes a certain time to travel through atoms. So there's a consistency between locations. So if light coming from the same area of a filament will likely be in phase because all of those places are, the lightning is going through them at the same time. So close enough to the same time. So areas of a substance will all be producing light that's pretty coherent because the lightning, the electricity traveling through them is going to be traveling through them at pretty much the same time. Even if it's moving in different directions, it got there at the same time.
These problems are much less because laser, the coherence length is much larger. For quite some time they will be in coherence and so on.
See, it says that for quite some time they'll be in coherence when, well, we know they'll be in coherence the whole time. Lasers don't get funky as you leave them on longer. They all of a sudden producing sillier light or something. So he sort of, this is getting to the ray length argument. So the idea is the laser is producing rays of light that are a certain length. And so again, this is an argument about, inside of this length could be 100 photons. Okay. So, he's saying it sends big chunks like that. But when you send another chunk, the chunk could overlap, or the chunk could be way behind for the next big hunk of laser light. And that somehow this is accounting for the irregularities creating the X spot, the dark spots in the pattern, when obviously those dark spots are always there. So it doesn't have anything to do with misaligned rays of coming out of a laser. And obviously we just don't see any difference. The first light that comes out of the laser is just as good as the last light that comes out of it in terms of showing you something. It's never changing.
Okay. So that's it.
Lasers don't become incoherent. It's always producing the same, tends to be coherent light.
Is it? Okay, that single slit thing. I talked about a very narrow slit so that I don't have to do that bit by bit addition and so on. But if it is slightly wider slit, so if you have this kind, and then you are looking at the intensity here, then you should take care from here, take contribution from here, 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 here.
So he's doing the Huygens thing here, which is just a joke, right? Because there's always going to be the fact of the distance of the opening, and that's all there is. And all there is a certain number of wavelengths, and those certain number of wavelengths will be reflected on this. And that's all. It'll be the same number. So just take the distance of the slit, how many wavelengths of light fit in that distance, and that will tell you exactly how many bars you're going to see in any 90-degree arc. And so you just multiply it by 2. You just take the number of wavelengths that fit in the slit, multiply it by 2, and that will tell you what a 180-degree arc, how many bars there'll be on it. The end. It's that simple. There's nothing else happening. There's just the number of wavelengths distance. You can't draw the vectors. There's no more vectors than there are wavelengths. And that's all there are. There's not an infinite number of sources and an infinite number of vectors. There's only the wavelengths that constructively and destructively, as they say. And we're really talking about the ones that constructive. So we're just basically saying, look, where can you put photons back in phase? And there's only a certain number of those locations in this arc. In a 180-degree arc, there's only a certain number of locations where it could ever possibly be back in phase. And that's simply dictated by the two surfaces. Those are the point sources. If you put the point sources any other place, you won't get anything rational. Period. Alright, so I think I've done my job, blah, 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 blah. We'll play a little more just for fun.
I had shown you to some extent, leaving out some trigonometry, that if you just add 2, what happens? Now you have to add many. Right? You take dx, 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 dx and integrate over this. It's not countable.
So he's saying if you integrate over all this stuff, you'll figure out that they all cancel out. And what you're really, again, what you're really stuck with is how many wavelengths, how many nodes where the wavelengths will be in phase. And it's completely dictated by the number of wavelengths of the distance. And that distance, again, has there's two sides to it. Okay, the slit, which way to draw it? I'll draw it this way. Again, they create a pattern going this way, contributions from scatter going that way, and contributions caused by scatter going this way. So you always have to keep in mind that the number of nodes, the number of places where these lines will end up converging in phase, this line plus this line, is a certain number that's completely dictated by how many wavelength nodes are in the distance. And so if this is 7 wavelengths of distance, then you'll have 7 nodes on this side and 7 nodes on this side. And that's it. No infinite pattern, no any of this nonsense. That's all you have. That's it. No more than what you started with here. Okay, this distance tells you how many wavelengths that tells you how many nodes where you can combine to create a constructive reconstruction. Oh, sorry. I didn't show that properly. Got a little lazy. Alright, so I think you got it. Okay. So that really, it's... way to go, Gary. Hey, that was fantastic. You've explained something that was a mystery 200 years ago. You explained something that was a mystery to Newton. You've explained something that every single physicist known to mankind hasn't explained correctly. Every single YouTube video ever made doesn't explain correctly. Khan Academy, Feynman, Lewin, Susskind, none of them have done it right. You did it right. Great job. Thank you. Thank you for doing something really frickin' brilliant. That's what should be happening. Okay, the whole physics world should be applauding me right now, saying thank you. Thank you for providing it. I mean, you fixed it. It was all such a mess, and it was so, oh, gee, none of it really fit together, and it just confused everybody. You made such a horrible mess, and now you've made it so easy and so understandable. And yes, okay, this doesn't look very wavy, and so I am, you know, oh yeah, I'm really, you know, wave particle duality. Well, you can keep it, okay, it's okay with me. You have even less evidence for the wave part again. There really isn't any duality. But anyway, you know, yes, I know that's going to hurt you so terribly that you have to, oh, waves didn't win again. Shoot, you know, I know it's not your favorite little red car in the race, you know. You're rooting for the wave guy or something, the wave shirt or whatever the fuck it is, you know, the wave hero. Yes, it hurts the wave hero. But look how simple it is, and it fixes something. We don't have to talk about it anymore. It's completely done. It's not really interesting anymore at all. We got rid of something that was just frustrating and irritating. And you should be applauding and thanking me. But instead, I'll just get cheap, shitty ridicule. You know, and nothing like a rational response. So me having less than a charming attitude is probably understandable. Yeah. Okay. So anyway, till the next time when I continue to prove, and I mean absolutely prove, a bunch of smart people to be dumb, motherfucking cunt, shit, arrogant jackasses. Because that's the other thing I'm proving. Not only am I proving that physics is mechanical and simple, I'm also proving that a lot of human beings suck as humans. They just suck. They're just arrogant, self-aggrandizing, pudgy shit for brains. You know, we're walking around feeling all superior. And they have no good reason to. Because they, you know, they didn't do any of this right stuff. They just did a bunch of sloppy gremlin bullshit. Anyway, I'm just ranting. So anyway, until the next time. Again, when I just continue to do perfectly solid proving and get no reward for it whatsoever. Because I'm on planet Earth where we only reward imbeciles and idiots. Alright, so until the next time and such. So, I'll endeavor to persevere. That's all I can do. And sue, of course. I'll do some suing. Endeavor to persevere, sue. Yeah, those two things.